Good Saturday morning, grade 12s. I hope you're having had a good week so far. I haven't given you very much this week, and I've been telling you I was going to give you a lab, so I'm going to do that. Um, we're not going to have a quiz on Monday. I think I might move it till Tuesday or something. I just have to figure it out still. There's my family outside playing basketball. Ben's inside. Anyway, it's a beautiful day. But I have this for you. So this is brand new material too. Okay, so I went to the school and I got a few things and I want to show you this. This is, one of the things we do in grade 12 is springs. Now we didn't do this last year at all. Okay, so this is a brand new topic. And what I have is I have a few springs here for you. They're, as you can see, very stretchy. Okay, and here you can see this one sort of jostling up and down. And here's one. This one is a very thick one this one's really hard to compress. Like I can't compress it. It's from a shock absorber from a car. Okay, and the thing about springs is that they're elastic, right? So if I just go like this, it reforms its shape, okay? And that's the thing about springs, is that they are an elastic system. And remember, elasticity is the tendency of an object to reform its shape once it's deformed. I'm going to take this hook off. Here you can see the spring, okay? And I've lined it up with a ruler. And so one of the things we're going to investigate is just how when you apply a force to a spring, how that affects its shape, okay? So I've lined up, if you can see here, I've lined up the bottom edge of the spring with the top of the ruler, okay? We would have done this lab together in class, so I'm going to do it for you. Now, the mass here that I'm hanging on it is 50 grams. Okay, now if you look at this, just wait for it to stop vibrating. It goes down to about, 2.3 centimeters or so, okay, with 50 grams on it, okay? And then what you do is you take these little weights that I have here and you can sit them on this pan like that. Now that is, I don't want it to bounce. That's the total of 100 grams. And then it goes down to about, 5.1 centimeters there. Okay. And then what I do is I take the 50 grams off and now I'll put 100 grams on it. So the combined mass of everything, okay, is 150 grams. Okay. And then I record the new stretch, and the new stretch is around 7.8 or so. Okay, if you can see it there. Okay, and then we repeat this. I add more and more mass. It stretches it more and more. Okay, and then I record the equilibrium stretch, like how much the spring has been stretched in the process of hanging mass onto it. Now there's a second part of the lab where I actually put couple 100 grams on this, okay? And then, actually I can't remember exactly how much I did, I'll have to do it again. But anyway, then what I did was I lifted it to the unstretched position, okay? And this is the second part of the experiment, so now there's zero stretch, and then I let it go, okay? And then what I notice is the maximum stretch. Now it's a bit hard to read it, okay, but I did the best I could. This is called simple harmonic motion when it does this. But anyway, that's the experiment. Now, I've recorded the data for you. I'm going to post it on OneNote, but I just wanted you to see the experiment, and then we'll talk about it later. I'll post another video. All right, thanks.